two variables. If you recall, we had to find the degree of each individual term, and we did that by adding the exponents. All right, so if I take a look at this right here, if I add up those exponents, I get 7. So the degree of that term is 7. When I add up the exponents in that term, 5 and 3, that gives me an 8. So there's a degree of 8. This one just has a degree of 2. All right, and then that 9 does have a little imaginary, say, x to the 0, y to the 0. All right, what? Because anything raised to the 0 power is always 1. So that's why you don't see those on constants. All right, so that degree is a degree of 0. All right, now for multivariables, all right, when you got more than one variable in your polynomial function, you find the degree of each individual term. The one with the highest then is the leading term. All right, the one with the highest degree is the leading term. All right, now I notice that I boxed in that negative that's in front because that term is a negative term. So when I answer the question for the leading term, I'm going to write down negative 8, x to the 5th, y to the 3rd. I'm going to write that whole thing down. I'm going to make sure and include that negative. All right, now the negative, the leading coefficient is a number that sits in front of the variables. All right, so that is just the negative 8. But again, that negative has to be there because of the negative that's in front of that polynomial term right there. And then the degree of the polynomial is the degree of the leading term or the highest degree in there. So on this one, by coincidence, it turned out to be 8. Has no bearing on that leading coefficient in the term right there. This 8 is coming from the fact that I added the 5 and the 3 to get the degree on that. So the overall degree of that polynomial is 8. Okay, so again, we had done that relatively early in the semester. All right, but all of these things are relatively simple and they're going to be on test number 1. So I definitely wanted to touch on those. Now let's just do still review, but one more thing. I want to kind of box this off a little bit because we're going to address it with more than one function. We're going to take a look at add, subtract, multiply, and divide, function notation just in general. All right, so let's suppose you would be given maybe a nice little small functions. F of x equals a negative 2x minus a 5, and then maybe say a g of x is equal to a 3x plus 4. All right, just a couple functions there, one called f, one called g. All right, now from that, I should be able to do lots of different problems. We should be able to do or know what an f and a g kind of squished together means to do. We should know what a 3 in front of, say, an f of x means to do. And then we should know just a plain, maybe say g of negative 6. All right, so again, this was, I don't remember exactly what lesson we kind of looked at function notation in. All right, but this is just a few samples of what function notation can be. When you have variables squished next to each other, there and there, it always means multiply. So the same thing here, this means to multiply, except what they're telling you to multiply is the f function times the g function. Okay, so f and g are not the variables, they are the names of those functions. All right, this happens to be a binomial. This happens to be a binomial, so this is no more than multiplying two binomials. So a negative 2x minus a 5 times that 3x plus 4. All right, so that would be a nice little FOIL right there. See if we can do the whole thing in our head without showing the middle steps. That would be a negative 6x squared. This would be a negative 15x. This would be a negative 8x. So negative 23x. And then a negative 5 and that positive 4 there is going to give you the negative 20 on the end. Okay, and doesn't say anything about factoring. It just says multiply. You're just given this, evaluate these. Okay, now on the next one, a number squished up against a letter, anything else, just like that coefficient right there, squished up against those means to multiply. So same thing here, that 3 is butted up against that f of x, so I'm taking 3 times f of x. All right, now let's go ahead and work that out. F of x is a binomial. All right, so a 3 on the outside times the f function there, which is the negative 2x minus 5, which is basically just a nice little distributive property there. So we'll take that 3 times each of those terms inside there. So a negative 6x minus a 15. All right, so again, pretty straightforward there. All right, this g of -6, all right, is saying take the g function and put it in, I'm sorry, take the -6 and put it into that g function. All right, so think of it as inserting it into that. All right, so if I were going to, depends on how you might do it, you could just go equals right after the problem, and then that way you wouldn't have to write that again. So that equals a 3 times a -6 plus a 4. Going down there, -18 plus a 4, which will give me a -14. All right, so again, just a little bit of basic review there of our functions, our function notations, and the types of questions that you could expect to see like on that first test number 1. Okay. All right, any questions so far?